All right, this is SAT Prep. We're doing test 3, section 4, and this is number 23. So note the figure is not drawn to scale. Remember, you can count on that unless they tell you otherwise. So the angles shown above are acute, and the sine of A degrees equals the cosine of B degrees. If A equals 4k minus 22 and B equals 6k minus 13, what is the value of k? So the trick, right, the trick here is to recognize that if the sine of A is the same as the cosine of B, right, we've seen this in triangles before, right? So let's just say that this one's A and this one's B, right? So the sine of A would be like this number on top of this number, right? So it would be what is considered opposite of A, so opposite of A over the hypotenuse. But the cosine of B would be this thing because it's the adjacent to B, right? That's the same side. It's adjacent to B over the hypotenuse. So basically, what we can get from this is that A and B, so what this statement actually tells us is that A and B sum to 90, right? They are complementary. They sum to 90 degrees. So if we know that they sum to 90, then we know that 4k minus 22 plus 6k minus 13 sums to 90, and that's enough for us to find k. So 10k minus 35 equals 90. 10k equals 125, so k is 12.5, and our answer is C. So this really does kind of hinge on you having that information that these values sum to 90. There's also a trig identity that you may see in pre-calc that tells you that the sine of 90 minus an angle is equal to the cosine of that angle and vice versa. So again, if you could notice, oh hey, A has to be 90 minus B, well then you'd be able to get this same relationship that they sum to 90. So there's a bunch of different ways to get there, but sort of the important missing information that you have to figure out there is that these angles sum to 90 degrees.